First of all, thank you very much for crossing the road and risking your life to come to my session. I nearly got run over by BMW just now, which is great. Okay, so today I'm going to talk about hardware development on the Raspberry Pi and on Arduino. But before I drill into these two platforms, I'm going to give an overview of the type of problems that IoT or modern embedded developers face today, and kind of like which kind of type of boards suit you the best. And so just to give you a background about myself, I am an electrical engineer from the University of Auckland, and I've been working at Intergen North America for a couple of years, and we've been working with Microsoft product teams to bring out products like IoT Hub and IoT Suite, which we can talk about later. But that's not today's session. Today's session is about embedded devices. Now, how many of you here have bought a Raspberry Pi or Arduino or that sort of board? Oh my God, that's a lot of people. Okay, all right. How many of you here has got a project that you have completed? Okay, okay. I'm actually surprised at how many people have put their hands up. Okay, so how many of you here are working in the industry, like embedded manufacturing, that sort of thing? Oh, okay, all right, cool. So today I'm going to try to straddle the divide between industrial and maker, and maybe take some of your projects that you've made and make it into a product, productionize it into deployment that's more than 3. Okay, so I have a problem. Okay, so these are the boards that I found on my desk collecting dust. I bought them as they came out. A few of them, I think that Beagle board in the middle, I can program with JavaScript. I was like, holy crap, that's cool. The one on the left is a Bluetooth and Wi-Fi module called Photon. It is really small and really, really amazing. But when I get these boards in the mail about 2 months after I ordered it, I plug into my computer, I start putting a few sensors in. I got this great idea about a particular project that I want to do. But I get stuck because the board I chose is probably not the best fit for the problem that I'm trying to solve, right? So that's actually quite a bit of a problem. So what I'll do is give a brief introduction into what type of board you should use for your project. Okay, let's start with the simple ones. Okay, that's not supposed to be scary. It's a display board, LCD display on top. I think that's a barometric humidity sensor on the right, and probably a temperature sensor at the bottom. It's a weather station. It just collects data by itself. It logs the data on the device itself. It doesn't send the data anywhere. Okay, that's quite simple. And then you get these really cool looking Back to the Future self-tying shoe, which, if you think about it, is only a battery, a board, and a motor, and a button. Yeah. So that's quite simple, quite standalone by itself. And then you get a really cool laser turret thing that can entertain the cat for hours. And in the end, if you think about it, it's a laser that has a battery inside. It's got a little probably three axis of motion robotic arm, and then you just feed random values into it. These are quite simple, really low-end devices, projects. And this is where microprocessors really shine. The one on the bottom right is my final year project at uni, and it is a 200 megahertz Texas Instrument digital signal processor, which like back then was like, holy crap, this is like the top end device that we can get. Because if you think about it, we're working with 1 to 8 megahertz during uni, and in actual deployments, you're probably gonna go up to about 50 megahertz, and that's more of a powerful device in a way. So these things are quite low power, they're quite simple, but at the same time, they could be a bit of a pain to work with. just because you're gonna have to deal with really low-level languages. And even though it has quite a few add-on pins and modules that make it easier for you to work with the motors, like say the PWM module, the pulse wave modulation module, makes it really easy for you to work with it. But at the same time, if you want to deploy these out into field, you gotta think about how do you make these in production, how do you test that every single one of these devices work. So you probably want to limit the scope of your project if you are using a microprocessor. And it is traditionally, historically been hard to work with it, but now that we have great stuff like Arduino, and I think the Texas Instruments has got links into Simulink and MATLAB to make the programming a lot easier. We'll get to that later. But as you go up this level, go up the stack a bit more complexity, having some sort of graphics processing, some sort of image processing on the right. That one is actually a Channel 9 video, which is kind of cool. They put a little hosted web app in a Raspberry Pi, and it's a magic mirror. So it has a webcam on top, it's a mirror in the middle. It's got a transparent screen, I think, in the middle. And so it recognizes your face and greets you in the morning and tells you the weather. Pretty neat. But these other kind of projects that is kind of stretching the microprocessors because they have internet connectivity, and I really, really, really don't want to work on the image processing project in C. Well, not 50 megahertz at least. And as you have, okay, sorry, I kind of grabbed this diagram from the internet. It looks a little bit scary, but you have these really simple devices and sensors on the left over here. And you want to get it into the cloud to do some sort of processing. In the middle, there has to be some sort of device that aggregates these type of data and make it so that you can send the data across the internet securely using TLS and not using the default username and password like the DDoS attack a while back. And this is where single board computers really shine. Now, I'm pretty sure most of you already know what single board computers are, but let me just give an overview. Single board computers are just tiny PC. Don't overthink it, that's it. It runs some sort of embedded operating system, probably Linux, and now Windows. And they've pretty much been kicked off by the Raspberry Pi a while back. With the $35 price tag, anyone can go in there and start developing their own embedded solution. And because it's Linux, if I got an image processing library that I want, I can just do apt-get install OpenCV, and here I have it in my project, which just kind of opens up a world of possibilities when, before you have to deal with C libraries. And of course, even though it is just computers, they still have I/O pins for you to work with these sensors. They have UART ports, they have serial communication for you to talk to them. And then they're cheap-ish. They are about an order of magnitude more expensive than microcontrollers. So if you are selling 1 million of these, the cost is going to be a big concern. But when you're deploying it at hundreds or thousands of these devices, it's actually quite cheap compared to small computers like the Intel Compute Stick. But as I want to move up the stack, get it? Stack, because it's stacking. I want to add more and more modules to it, like Wi-Fi, some sort of cellular modem, if it's running by itself. Accelerometer, perhaps, some sort of display to interact with. And this is where it gets really clunky, and you probably don't want to be doing your prototyping using these small computers. And that's actually, quite interestingly, where mobile devices come into play. So you know those registration tablets that you have in the hub over there? They're running iPads. They're great because you get, because of the high levelness of the operating system, you get tools like Microsoft Intune for you to do device management, remoting into it when it breaks, which is really good. And if you think about it, it has Wi-Fi, 3G, Bluetooth, GPS, accelerometer, a display, obviously, and also a touchscreen. And these are just sub-$100 devices. And it's actually great for you to do the prototyping if you want to deploy these. I actually talked to a bunch of people in Melbourne who were doing a tablet deployment around a train station. And so basically they have these little kiosk things that they can go and check the bus timetable, which is actually turned out to be quite easy for them to manage. Oh yeah, and the one over there is the Panasonic ToughPad, which has barcode and magstripe reader for you to check out someone. But we're not talking about mobile operating systems today. We're gonna talk about Arduino to start with. And Genuino, I believe is the name for Arduino outside of the US, but I don't care, I'm just gonna call it Arduino. Okay, so the Arduino started off as an open source platform a while back. They said it was gonna be open source from hardware level to the software level. So everything that you get in there, you can take apart, you can sell it at your own price. And I think the licensing is maybe MIT, I'm not too sure. And so at the beginning, some people were doubting how open it really is. So the Free Genome project, which I mentioned up there, basically took the entire hardware and software and then replicated it and started selling it themselves, and just to test how open it is. And Arduino hasn't done anything to them, and they've been pretty open since then, so which is good. And I think Free Genome hasn't been maintained for a while just because there's no need. And if you read the website, the tagline is that it's for students, hobbyists, artists, programmers, and professionals. You see how the professionals are at the end. It's quite interesting because if you go to these engineering embedded programming forums like AVR Freaks, at the beginning of the Arduino movement, there are these engineers talking about making condescending comments about the Arduino, saying how it's too easy, but it's supposed to be hard because it's hardware. Right? Sorry, that's a really bad joke. But yeah, but the good thing is that it's actually taken off because of the open nature of the platform. The electrical specifications is open to anyone. So there's a whole bunch of companies that came together and just made these shields, which are basically little sensors with ports that can plug into the Arduino, and you can just stack them up as you go along, which is really cool because if you have a prototype and you want to add a new sensor, like the humidity sensor, plug it in, and there you have it. So to interact with the sensors that comes out with the Arduino, you have the one choice called the Arduino programming language. It is based on wiring, which is based on C/C++. And for all intents and purposes that I know of, you can consider that as C. I believe there are some edge cases where it doesn't cover, but the idea is that it's pretty much C-like. And you can drop most C libraries into an Arduino resource if it's within its resources, and it should be able to run. You see how there's a lot of should, may, as I mumbled on. But yeah, so the idea is that you are able to get started really quickly. That goes back to the whole target of non-programmers. And the idea is that the Arduino programming language kind of hides away the nasty bits from you, like the makefile, the registers. Okay, so on the microprocessors, if you want to set a particular pin to output, say, what you gotta do is you gotta look up the data sheet to find the actual register that this setting is in, and you have to find a bit value that that pin corresponds to, and you have to write in like literally zeros and ones into these registers to turn them on into input and output. And it's just so much pain. And the Arduino language kind of abstracts that away from you. So you can work with any of the Arduino programming boards, and you shouldn't need to look at register level, at least for most cases. On the flip side, most of the Arduino chips run on Atmel. Atmel is a pretty big chip manufacturing company. So if you want to take your prototype into production, you can, because you have the circuit boards, you have the electrical stuff sorted out for you. And also you have a chip maker that can supply in the tens of millions, right? And the idea is that you can switch from an Arduino project into ML Studio really easily. Talking about Arduino IDE, it is supposed to be for known programmers, which I'm pretty sure none of you guys are interested in. But the idea is that if you want to start a new Arduino compatible board, all you have to do is provide a JSON file that kind of says what your board is capable of. And as long as it meets all the criteria for Arduino compatible, other people can start programming your board using the Arduino IDE. Whereas with ML Studio, like I said, most of the chips for Arduino are run on ML. You get this Visual Studio-like environment, which you can use to develop on these chips. But then again, because Arduino is becoming bigger and bigger, and it's not just ML, you will get into Arduino compatible boards that isn't supported by the ML Studio. And so this is where this new extension called Visual Micro comes in. It is supposed to work for both ML Studio and Visual Studio, which I'm not exactly sure why ML Studio, just because they already have that. It supports all of the Arduino compatible boards, and it runs on any version of Visual Studio. I believe if the newest Visual Studio comes out, they'll have to catch up a little bit, but the idea is that they'll catch up to it eventually. Whereas ML Studio, I think only recently, they released a really big update which supports Visual Studio 2015. And I think they locked down a few features in there as well. So if you want to work with the Visual Studio version that you've already got, and you're familiar with the workflow, Visual Micro is actually pretty good. Okay, so without further ado, I am going to give you a demo of the Visual Micro extension. Let me just hide down there, 7. Ooh, okay. So unfortunately, we don't have the document camera in here, so I'm gonna have to make do. Okay, so if you can see on screen over here, this is a ultrasonic sensor. It is a distance sensor that goes up to 8 meters, I believe. And it is attached to an Arduino Uno. The Arduino Uno is a deprecated board from Arduino. It is, unfortunately, I bought it back when it just came out, and I was like, this Arduino runs Linux, that's awesome. So I bought it, and then they deprecated it. But they do provide a Uno shield, which is a shield that you plug into the normal Arduino. And so you get the Linux on top of that, which makes a lot more sense if you want to think about separation of concerns. Okay, so what I'm gonna do is I'm gonna use Visual Studio to program this Arduino to get the ultrasonic sensor data. And let's just move that back a little bit. And this is the wrong project. All right, before I go into that demo, actually, let me just show you how you install Visual Micro. You go into Extensions and Updates, you search for Arduino IDE for Visual Studio, Visual Micro, and then the first result should be done. Next, once you have that installed, it will ask you to install an IDE, And in this case, I got Arduino 1.6, the normal IDE installed, and they just use the build tool to build. And here I have a list of boards I can work with. Arduino Yun was detected the moment I plugged in my Yun, and it has all these other boards as well. And I believe they do compatible ones as well, so you can release your own version, and people will be able to find it. All right. And over here, I have a Arduino Hello World INO file. INO is the Arduino programming language file. Not too sure how you call that. And what I'm doing here is I'm starting a serial communication at 9600 baud rate. For those of you that had to work with the ATmega 8 back in the days, oh my God, you know how many of my paper, where half the paper is getting the board that you are to work? It is mind-blowing. One line, and it's done. And now, this is the Arduino setup loop. It runs once, function, it runs once, and then the loop over here is like a while one statement that just keeps on running. And so in this case, to interact with the ultrasonic sensor, the data sheet told me to send 2 microseconds, and then send high, and then wait 5 microseconds, and send a low. And then that's how it starts the sound wave process. And then what I'm doing is I'm waiting for the ping to come back, and then I measure the time it takes for the sonar to go out and come back. And they have a really neat little function that converts it back into centimeters or inches. And obviously, I'm going to go with centimeters here because we are not savages. Okay. So what I'll do here is, let me just start this program. Oh, is it on port 5? Oh, yes. Okay, it's working. Now it's 3.7 meters to the ceiling, which kind of feels about right. And here we go as it goes down and up. This tells me how far away I am to the board. And I just realized that you guys aren't seeing this. Here you go. Cool. Okay, that's pretty simple, right? You just plug in, and this serial port just pops out automatically. I didn't even need to configure any of the baud rates, which is pretty neat. But what you see over here is a little dot. That's a debug point. Again, for those of you that's working with high-level languages, this is probably nothing to you. But for us lowly embedded programmers, this is amazing. It took me like 3 days to figure out how to do printf without overflowing the stack. Let's put it that way, which is okay. So this debugger allows you to put in conditions. So you go conditions when CM. This is the variable name CM is smaller than 20 centimeters. So in this case, if I go below 20, you see how the output at the bottom is updating. Okay, and then it says too close. But I can also get it to say stuff like in function $function IntelliSense, and let me see, inches. Oh, inches. I believe that's going to update it so that it uses, it prints out the inches variable instead. So let me go ahead and compile it again. Remember, this is embedded programming, so what it's doing is it's actually programming a separate version of your Arduino code so that it has the breakpoints. And basically, they're inserting code into your code, which should be okay. You see how it tells me how many inches it is, like on the right over here, and it tells me what function I'm calling that from. So that's pretty much it. But to high-level programmers, this is nothing. But to us embedded people, yay. Okay, let me switch back to the next part. Raspberry Pi and Windows IoT Core. Okay, now, how many people here have heard about Windows on Raspberry Pis? Okay, how many of you know how it works? How many of you know what you can do with it? Wow, okay, that's great, because I'm gonna tell you every answer that I just asked, answer to every question I asked. So, it is not Windows per se, okay? Don't get too crazy. It doesn't have a desktop environment. It is a little bit similar to the WinRT operating system a while back on the original Surfaces. But this time, it's great because it runs universal Windows platform apps. So that means if you got an app that works for Windows 10, you port it over to Xbox, you port it over to HoloLens, and then now you get it on your little Raspberry Pi as well. It's like write once, run anywhere, right? It's amazing. Oh yeah, on Windows Phone as well. Totally forgot about that. You can run multiple background apps alone with your front-end application. So, and it's quite interesting how it talks to the background applications. I'll talk about it later. It runs on the Raspberry Pi 2 and 3 and Minnow board, and also the Qualcomm Dragon board, which is the same board that you get with the Google Brillo operating system, I believe, which just made it like an instant buy for me. So I bought two, haven't done anything with it. And as I said just now, it runs Windows UWP apps. It is exactly the same API as all the other UWP apps. Terms and conditions apply. There's some more APIs you get access to because it is IoT, but you also lose a few APIs that's only specific on the phone and on the desktop. I'll get to that later. But the great thing is you can work in XAML now. Like, I absolutely love working with XAML and just being able to make UIs in Blend and then have it data bind to everything using MVVM pattern. It is amazing. So now you can finally use XAML apps on the Raspberry Pi. And I think TaylorWork has controls that work with the Windows IoT Core as well. So that's pretty cool too. And obviously you get the HTML and JavaScript, hosted web apps, C++, Visual Basic, that sort of thing. And you also get known UWP apps. These are Python, Node.js, Arduino, and also a Win32 console app. And again, terms and conditions apply. There's a porting tool at the bottom that tells you if you got a legacy application you want to port over to IoT Core, you run that tool against your EXE, and then it will tell you which APIs you're using that's not supported, and you can kind of choose what you do with it. Okay, so first of all, Arduino wiring is pretty neat. So if I got the project, kind of like the sensor sonar project that I just worked on for the Arduino, I can put it over to Raspberry Pi with ease. And yeah, and you can wrap these Arduino code into a little WinRT components for other languages to consume. So if you're familiar with WinRT components and Windows 8 application, these are little containers, if you will, for apps. And you can basically have JavaScript calling to C# code using the interfaces or public methods that it exposes. And same goes with C++, Visual Basic, and in this case, Node.js as well. So Python is also supported, but at this moment, I'm not too sure whether you will it's a good fit for you, just because it doesn't support any of the other UWP APIs, nor does it get nor can it call into WinRT components. So it's kind of like standalone module. So if you got Python code that you want to run really quickly without having to install Python on Raspberry Pi, which isn't that hard really, you can do that. And Node.js application. I'm gonna show a demo of all these later on. But there's one thing that I didn't know about the IoT core before I started this presentation, which is drivers. Apparently, you can port your x86 drivers to IoT core if you have, if it supports the universal INF driver manifest, I believe. And so if you got a USB modem or some sort of printer and scanner or some sort of POS device, like barcode scanners, that sort of thing, you can kind of port it over if you got the universal INF drivers. There's a lot more details in the link up there, but basically what you do is you do an export on your PC and then import it. And the limitation for IoT core is that there's no user associated with it, so you don't get APIs like email, SMS messages, and Cortana because there's no shell. But because it is UWP, you can do stuff like speech recognition and speech synthesis, and these ones are kind of offline. But if you want to take it online, you can use the cognitive services, which is a really excellent speech recognition API that Microsoft has got. And there's a list of available APIs there. You guys can check it out in the deck when I make it available. All right, let's switch back to the Raspberry Pi. Okay, so apologies, I can't actually see what's up there, but this is kind of like the home screen that you get with the Raspberry Pi. And what I'll do is just unplug the USB, the mouse, so that you guys can see what's going on. Okay, so on the top left, you get this command line interface that you can do make CMD commands to. And there's a bunch of resources here to teach you how to get started with the Raspberry Pi, but you don't need to because you're in my session. You go into settings, you get some Bluetooth. If I got a Bluetooth dongle, I can plug it in and it will list all the Bluetooth devices in the vicinity. You get this Wi-Fi interface for you to connect with, which is really, really nice. If you, I had to, when I was working with my first Raspberry Pi in Linux, I had to go into these really weird manifest files to put in the SSID and the password, and it was a nightmare. But now you get this, and it also prints out the IP address right there on the front screen. So it is really easy to work with. Okay, let me take this to desktop. Okay, so what I'm gonna do here is disconnect the sensor from Arduino Uno, and then connect up the Raspberry Pi into it. For the record, you are not supposed to do this because the sensor runs on 5 volts. And what I'm doing here is I'm hoping the Raspberry Pi's diode will be able to take the blunt for me and it doesn't die. And also for the record, black is ground, red is power. So if you ever get asked to defuse a bomb, try the red one first, I guess. Don't quote me on that. All right, now the transfer is complete. Let's see some code. All right. Okay, so I'm gonna comment this. I should have done this before. Okay, so this is some very simple Arduino code. Let's start with that, okay? What I'm doing here, again, this is the same setup and loop that you saw before. And I'm basically turning the LED on and off. Okay, let's see that in action. And what I'll do here is I'll hit F5 because I've already set it up to do remote debugging to the Raspberry Pi, which is kind of neat because I just get it to, I'm able to program it directly. And so it's gonna start copying the files over. And so I can treat this just like any Windows computer and do debugging. So say if I put a breakpoint in that, see how it stopped. I go, okay, that's cool. What's the LED pin? You get the exact same high-level debugging. Okay, so if you can see the light is blinking, yay. Okay, cool. Now that we got the most simple Arduino code going, let's get a slightly more complicated code going, which is the sonar that we were talking about. And so this one's slightly more complicated. I am, again, setting you see the 2 microsecond and then 5 microsecond handshake, and I calculated the duration. Exactly the same functions. I just made it a little bit simpler. And then because I don't have serial on this machine to make it work really well, to visualize it, so what I'm gonna do is I'm gonna get it to turn the LED light on when it's too low, when it's too close. So what I'll do is, okay. It's doing the deployment. Light is up there. Cool, and I think it's running. I can hear the sound. And see how it's off. Are you guys able to see it? I think the saturation might be a little bit too bad. Okay, so as I get closer, the thing turns on. As I get far away, it turns off. Yep. Okay, pretty simple stuff. Okay, let's get funky. Now, I talked about WinRT components. So what I got here is a little Arduino LED library. Let me just hide the files I don't need to look at. This is the same Arduino code that I was using to turn the LED on and off. What I did was I packaged it up into WinRT components, and I'm calling it from C# over here. So this is a C# console application that goes into the Arduino LED library, which is the one on top. And I'm calling into the LED controller class, which is actually in this C++ file over here. And then it will turn the light on and off every 500 milliseconds. So this is just standard C# .NET API. And so I'm gonna set this to startup, and I'm going to run. Oh, one thing is, with the Visual Micro SD extension, it kind of messes up your C++ file, because when Visual Micro last released, Visual Studio hasn't got the Arduino compatibility, and now that Visual Studio can work with Arduino files directly, there's some conflicts. So what I have to do in between projects is to go into configuration manager and then just kind of get rid of that path over there. And then so it doesn't, Visual Micro can't find the build and doesn't go around and adding weird things into my C++ project. So that's one thing that you have to remember, because I was up until 12 o'clock this morning, or 12 o'clock and 12 p.m. right now, trying to figure out why my code wasn't working. So this is C# code that's running on the Raspberry Pi. And as you can see, the LED is off. And so if I just keep on running, it's going to stop blinking. Yay. You can see that, right? OK, cool. So we just proved C# going to Arduino. How about something else? Let's do Node.js. So what I'm going to do is I'm going to set this to a startup project. And in here, I have the GPIO on and off, GPIO controller that you see over there. But I'm not going to use that in a WinRT component. I'm going to use this over web. So I'm going to create a web server, a Node.js web server running on the Raspberry Pi, and code into that using my browser. OK, hopefully this works. It should. OK, I need to not Chrome, because that's where the request lost. Blah, blah, blah. I think it's this one. OK. Oh, hey, thanks for following. So if you want to follow me, use range DSP. I'll have it up there. OK, so I think it's running. And so the only thing that I can do to verify that it's running is to, first of all, find out the IP address where this thing is running, which I don't actually have handy, unless it tells me right on the big screen. Sorry, 2157. It's pretty handy, eh? OK, so I have just turned the LED off. As you can see here. And so what I'll do is I'll turn it on. Voila. Did you guys see it? Did you guys see it? No? OK, how about this? Do you see it turning off? Oh, wait, where is it? All right, let's go forward. Turn it on. OK, so it's very hard to control this when I have to use the keyboard and touch this. Oh, actually, I have two hands. Look at that. OK, so all right. So now I am able to. Well, I think most of you guys got that, right? I can turn it on and off using the web, which is pretty damn neat. Just because Node.js is really good at spinning up small APIs. So if you got a whole lot of these small devices running on the same network, you can have it talking using HTTP request as opposed to using good old serial, which isn't good nor is it too old. All right, and that's my demo for the day. This is a really nice IoT dashboard that I use to program the Raspberry Pi with. And so as you can see, what I'm doing is plugging the SD card. I choose the version I want to run on. I choose the Wi-Fi network. So by clicking it over here, it passes the Wi-Fi password to the device. So you don't even need to touch the device to set up everything. And then it just downloads the ISO file for me and then image it, which is pretty neat. What next? Connected to Azure IoT, IoT Hub, IoT Suite, do whatever you want. And I think I'm going overtime by quite a bit. So I'm going to just leave that up there and open this up for questions. Thank you very much. Cool. Question? Yes? So the question is, do I do this for a job? Yes, I do this for a job. It is great. I am working with IoT, Microsoft product team, so like they will have these tiny little demos, and I just make a hands-on that for them. Next. Quiet crowd. Oh yeah.
How heavy is the load on the Raspberry Pi?
Sorry.
How heavy is the load of the application on the Raspberry Pi when you use?
Okay, so the question is, how heavy is the load on the Raspberry Pi? That's a great question, which I can answer right here. I go to 8080, type in admin password. Caps lock. Okay, here we go. Performance. CPU, memory. Well, it looks of it, it's not too heavy, but I'm guessing it's because they are in background, running in background. So if I start up, say, the LED wiring, we can probably look at the performance impact. Ooh, it's actually running, funny enough. Okay, so it's apparently not very heavy, and I think obviously if you got UI apps, it's gonna take the brunt of the processing. Next. No questions. Does it get updates at all? Yes, it does. So this morning at 3 a.m., I got an update in the middle of my deploying to it. So I was wondering why it wasn't working. So I brought out my second Raspberry Pi. I bought another SD card, started deploying to it. It won't work because it's updating, because it's all connected to the internet, so it does the security updates. Yes?
What's the development kit like? Is it just like literally when you've got the green board, the Raspberry Pi, any extra stuff, or is it?
Okay, so the question is whether there's extra stuff that came with it. So no, with the Raspberry Pi by itself, the single board computer actually just that. I think they don't even give you like power cords. But there is a whole bunch of kits out there that you can do. Like this one they sell on SparkFun. You go to JCar, you pick up one of these kits. It's got everything that you need. Cool. So to get started with a Raspberry Pi, yeah, you just need the Raspberry Pi and plug into a computer. Just because Raspberry Pi is a Linux computer, well, now a Windows computer too. Cool.
Is there a good place you recommend to go for interesting things or fun things to do with the Raspberry Pi?
Okay, the question is where to go for interesting ideas. I have personally found Instructables pretty good. Okay, so that's a little bit too high level. There's SparkFun. They have a bunch of interesting projects. There's Hackster.io, I believe, and they have a bunch of really cool projects as well. And so you just choose the category you want, and then it basically gives you a step-by-step instruction. Cool. Next. You're yawning, right? No, okay. Next. Any other questions? Oh, feel free to come up here and talk to me. I can chat about anything.